For almost half a century, a tiny machine has been traveling through a place no human being has ever visited. It left Earth in 1977. Back then, the world still had typewriters, cassette tapes, and computers that could barely fill a room. Voyager had no idea where it was going, and neither did we. Today, that spacecraft is billions of miles from Earth, traveling through the space between the stars. But here's the strange part. For decades, we had only one lonely messenger telling us what that region of space was really like, until something happened that changed the story. Voyager was not as alone as we thought, and what its twin discovered would force scientists to rethink what lies beyond the protective bubble of our sun. So, what exactly did Voyager find out there? And why did it take us nearly 50 years to realize just how strange the space between the stars really is? To understand that, we have to go back to the beginning. When Voyager 1 and Voyager 2 launched in 1977, nobody expected them to become humanity's longest-running explorers. Their original mission was much simpler: visit the outer planets. Voyager 1 flew past Jupiter and Saturn. Voyager 2 did something even more remarkable, continuing on to Uranus and Neptune and becoming the only spacecraft ever to visit those worlds up close. Then their planetary missions ended, but the spacecraft kept going and going and going. Imagine throwing a message in a bottle into an ocean without knowing where the ocean ends. Now imagine that bottle keeps transmitting information for decades. That's essentially what Voyager became. Except this ocean wasn't Earth's. It was the solar system itself. And eventually, Voyager would reach something no spacecraft had ever reached before: the edge of the sun's influence. But there was a problem. We didn't really know what that edge looked like, because the sun doesn't simply sit in space, surrounded by darkness. It blows an enormous stream of charged particles outward, a continuous wind that creates a vast protective bubble around the solar system. We call this bubble the heliosphere. And somewhere beyond it lies interstellar space, the space between the stars. Voyager 1 approached that boundary first, and then, in 2012, something extraordinary happened. Its instruments began detecting a dramatic change in the environment around the spacecraft. Voyager had crossed the heliopause. Humanity had finally sent a machine beyond the sun's protective bubble. For the first time, we were listening to the environment between the stars, and Voyager was telling us something unexpected. Scientists had imagined the boundary of the solar system almost like a wall. You approach it, you cross it, and suddenly you're outside. Simple. Except nature rarely cooperates with simple diagrams. Voyager's measurements suggested that the boundary was far more complicated. The solar wind didn't simply disappear. The magnetic fields didn't behave exactly as expected, and the environment beyond the heliosphere turned out to be far more dynamic than scientists had imagined. Then came something even more interesting. Voyager detected waves in the surrounding plasma. Now, when we say Voyager heard something, we don't mean there was an actual sound traveling through space. Space is essentially silent. Instead, Voyager's instruments detected changes in the electrically charged gas surrounding the spacecraft. Think of it like dipping your hand into a swimming pool. You can't see every molecule of water, but you can feel the ripples. Voyager was detecting the cosmic equivalent of those ripples, and these measurements gave scientists something incredibly valuable: a way to study the invisible environment surrounding the spacecraft. But there was still one problem. We had only one spacecraft out there, one perspective, one set of measurements. It was like trying to understand an entire ocean from a single bottle floating on its surface. Then Voyager 2 arrived, and suddenly the story became much more complicated. On November 5, 2018, Voyager 2 crossed the heliopause. 41 years after leaving Earth, it became the second human-made object to enter interstellar space. And this changed everything because now scientists had something they had never had before: a second point of view. Voyager 1 and Voyager 2 were traveling along different trajectories. They weren't following the same road. They were sampling different regions of the boundary surrounding our solar system. And when Voyager 2 began sending back its measurements, scientists noticed something fascinating. The two spacecraft did not see exactly the same thing. The heliopause was not behaving like a perfectly smooth shell. It was more complicated, more irregular, and more dynamic. And that meant the boundary of our solar system wasn't simply a rigid border separating our space from interstellar space. It was more like a turbulent shoreline, a constantly shifting frontier where the sun's influence meets the galaxy around it. And Voyager 2 gave scientists something incredibly rare: confirmation that the strange observations from Voyager 1 were not simply a one-off anomaly. But there was an even bigger implication. If the boundary is this dynamic, then what exactly is protecting our solar system from the environment beyond it? And how much does that protective bubble actually matter? Because the deeper Voyager travels into interstellar space, the more it is revealing about the cosmic environment surrounding our entire solar system. And that brings us to the strangest part of the story. There is something almost poetic about Voyager. A machine built by humans nearly half a century ago is still sending tiny fragments of information across an unimaginable distance. Its signal reaches Earth after traveling for more than 20 hours. By the time we receive it, the spacecraft is already farther away than it was when the message was sent. And yet, Voyager is not simply drifting into an empty void.